Today's lesson, we're going to talk about negative integer exponents and scientific notations. The first example we're going to go over is remembering law of exponents, right? So we have all these different types of law before. We're going to particularly talk about the negative exponents, right? Negative exponents, in order to get rid of this negative, you're going to flip the base, right? So x over 1 become 1 over x when you're getting rid of the negative. Same thing on here. If you have a negative exponents, get rid of that, become numerator become denominator. Later on, this chapter, we are also going to talk about fraction exponents. Fraction exponent is the numerator of the fraction is going to be power, denominator become a root, index, square roots, right? So for example, if we have 2 over 3, 3 on denominator become cube roots. 2 on the numerator is your power. And there is no order to it, so you can do the exponent first or exponent at the end. Let's look at some example. So this example is just making sure we know how to use the negative exponents with other rules that we learned from previous sections. Let's look at the example A. Example A, if we have x to the square on the numerator, x to the fifth on denominator, remember we can bring it up to the numerator and subtract, right, the exponents. This is going to give you x to the negative third power. If you have a negative exponent, in order to get rid of that negative exponent, we mentioned that we need to flip the base, right? And keep the exponent itself, just the negative sign will be disappearing by flipping the base. Let's look at the other one. So in this case, in order to get rid of negative exponents, 2 become 1 over 2 cube, which is going to be 1 over 8. Cube means you're multiplying 2 3 times, right? So it will be 2 times 2 times 2. What about this one? This is the negative exponents to the whole thing, including the sign. So that whole thing will become on denominator with positive exponents. It gives you 1 over 16. This one is a little different because this negative 2 exponents only apply the number. Why? Because you don't have a parenthesis here, right? So this exponents only apply the number, not the sign. So sign will stay same. Just the 4 will become on denominator and square, which will give you negative 1 over 16. So if you have a more than one term and you're trying to simplify it, something like example E, right? More than one term, trying to simplify it, what they're asking you to do is get rid of the negative exponents. When they say simplify, you should not have any negative exponents. So then you will end up getting 4x squared, y become 1 over y cubed. And because this is all multiplications, right, you can write it in one fraction form. Look like that. What about this one? I see 2 terms with negative exponents. So without the negative exponent, will stay on the numerator. With the negative exponents will become on denominator. Right? That's all you need to do. So again, if you have a negative exponent, flip. So the one on the numerator will become denominator with positive exponent, and denominator become on the numerator with positive exponent. So then if we're looking at this, negative 4 is positive exponent because no exponent means first power, right? X positive, 5 positive. Y negative cube become y cube on denominator. Z negative square become numerator z square. Let's look at another one. So this one right here, because the like base, right? You will combine this using the other law of exponents. So it means you can add them, right? That gives you x to the negative 8 exponents. Get rid of the negative exponent, it becomes 1 over x to 8 exponents. This one you can distribute, right? When you distribute, because you have two terms, you're going to distribute 2 times. So you get 4 to the negative third, y to the negative third. Negative means it will goes to denominator. And 4 to the cube becomes 64 and y cube. This one, you do have the like base, x and x, y and y, so you want it to combine. But you cannot combine if you have a parenthesis. So first thing we wanted to do is opening the parenthesis. In order to do that, you need to distribute negative 4th power. How many times? To the 2, x, and y. And if you do that, you end up getting 2 to the negative 4th, x to the negative 4th, y, negative 3 times negative 4 will be positive 12. This parenthesis do not have any other extra exponents to distribute, so just open the parenthesis. You get x to the negative square y. Because this is like term, you can combine. This 2 is the like term, you can combine. And you will get 2 to the negative 4th, x to the negative 4th, and plus negative 2 will give you negative 6. 12 plus 1. If you don't have any exponents, it means you have 1 there, right? So 12 plus 1 will be 13. So then now let's get rid of negative exponent by flipping the base. And we know what is 2 to the 4th exponent, which is going to be 16, right? And that's how you're going to simplify that expression. You get longer and longer, but then we already know all other rules. So we should be able to apply all that at once. Let's look at one more. I will be able to combine the like term because it's inside of parentheses, right? These two I'll be able to combine. And then maybe I will distribute, right? To open the parentheses. So inside parentheses, I will get 3x negative 1 exponents minus 2, right? In order to combine these two, I brought it up to the numerator, so I need to do subtractions. And then denominator, I will have the same thing as what I had before, which is y to the 4th exponent. This is going to be 3x to the negative 3rd over y to the 4th. And when you distribute that negative, you get 3 to the negative 5, x to the positive 15, and y to the negative 20. And let's get rid of all the negative by flipping the locations. Three to the 5th exponent. And if you know what's 3 to the 5th exponent, we can go one step further to show that is equals to 243. So this is how you're going to use the negative exponents on top of the other laws that we went over from different sections. One more example that we're going to do in this section is converting scientific notations into the regular number or natural number into the scientific notations or even decimal. So we need to remember the standard form of the scientific notation is a times 10 to the nth exponents, where a should be greater than equals to 1 but smaller than 10. And that's how scientific notation will look like. So if we're looking at this, I should be able to change this into 1.3 times 10 to the exponents. And the way that we're going to decide the exponent will be using how many space that you move this decimals to become 0.0013. So if you have a decimal between 1 and 3, you need to move 1, 2, 3 space to the left to make it smaller number, from 1.3 to make it 0.0013. So trying to make a smaller number means you're going to have negative exponents. Remember, it was the 3 space right from here to 1, 2, 3. So then you're going to use the power of 3. Making it smaller, so it will be negative. And 3 space will be third power. The reason we're using 1.3 is because if we decide to use 0.13, that's smaller than 1, right? That's smaller than 1, which is against the scientific notation statements range, right? Or if we want, so we cannot use that. What about if we wanted to use 13.0, right? That's going to be also over 10, which we cannot use it. So that's, again, out of range to become scientific notations. So it's important to make sure this first number right here have to be between 1 and 10. It could be include 1, but cannot be include 10, right? So then let's try another one. This one, it should be 3.2155. That will be only number that's between 1 and 10. Again, because we cannot use 0.32155 because that's smaller than 1. Or 32.155 is larger than 10. So that's something we cannot use. We can only use 3.2155 and times 10 to the what exponents? Well, if you're looking at this, in order to have decimal between 3 and 1, and in order to make the decimal all the way back to the 5, you need to move right 1, 2, 3, 4 steps. And moving in right directions, that's trying to make your number bigger. So your exponent will be positive 4. Let's try one more time. So this should be the first A part should be 4.21 times 10 to the, 4.21 to become 0.002, 0.00421, this number is trying to get smaller, so it will be negative exponents and how many space? Let me see. From here, it will be 1, 2, 3. So that's another negative third exponent. Let's look at the other example going backward from the scientific notations to the natural numbers or decimals, right? This is trying to make it larger, right? Because you have a positive exponent. Larger means you're going to move your decimal toward right side, right directions, right? So then you're going to have 4 space moving. So it'll be 1, 2, 3, 4. Means you're going to create 2 more 0 to have your decimal back there. So that's going to be 2, 1, 5, and 2 more 0. That gives you 21,500. Okay, so then let's try this one, the last one, negative exponents. Negative exponents means this number is trying to get smaller. So you're going to move your decimal 1, 2, 3 to the left. So you're going to create 2 more 0 then, right? To have your decimal points 3 space to the left. So that's going to become 0.001215. So I hope you understand how to convert from one to the other one related to scientific notations.